Hello, hello, and happy Monday. I hope you all had a great weekend, and I look forward to this week and what we're going to be covering. We're doing quite a few fun things to launch into this geometry unit. So this unit is our foundation of geometry. It's what we're going to need for as we're continuing on. So I want to start off with a couple small things between this and the next video, and that's the segment addition postulate. So postulates are things that we're going to use to prove certain theorems. A postulate is like a statement that you know is true. It's a fact, okay? It does not change. So the segment addition postulate is just that. And when I explain it, it's going to be super simple to you. You're going to pick up on it really fast because it's not something that takes a whole lot of evaluating. But the segment addition postulate says, let A, B, and C be collinear points. Just off the bat, I want to make sure that you know what collinear means. So that means that it lies on the same line, and this is really thick. I do not want my pen that thick, but we're just going to go with it. Okay, so it lies on same line. Okay, so collinear means they are on the same line. And if point B is between A and C, so if I have a point here, and I have a point here, and I have a point here, if B is between A and C, okay, and they're all on the same line, then that means the AB plus BC equals, I'll do this in a different color, equals AC. And well, of course, wouldn't that make sense? If the distance between Oxford High School and Taco Bell, okay, is a mile, which I know that it's not, but if it was, and the distance from Taco Bell to Walmart was 3 miles, then the distance from Oxford High School to Walmart would be 4 miles, right? That would be the way that we explain it. This is just a reasoning postulate, okay? So it's going to be pretty simple, but I just want to make it very as clear as I'm trying to get to the eraser, as clear as we possibly can. So let's do a couple problems involving this. So points E, F, and G are collinear. So that means that E, F, and G are collinear. Okay? And F is between E and G. Okay, so given that EF is 18 centimeters, so we're going to say that this is 18 centimeters, okay? And GE is 25 centimeters. So that means that the entire line is 25 centimeters. Find the length of GF. So this is what we're looking for right here. So I suggest every time that you have a problem like this, just drawing it out so that you have a mental picture of what's being asked. So we have part of the line and we have the entire line. So we know that the whole thing is 25, okay? So the distance from, the distance from Oxford High School to Jacksonville, okay, is 25 centimeters. But we know that the distance from Oxford High School to Main Street, Anniston is 18 centimeters, right? If we're looking at a map. So then what's the distance from, Midtown, Main Street, Anniston to Jacksonville? So that's what we're trying to find here. We have two pieces of the puzzle that we're trying to figure out what that last piece is. So in this case, you're going to say 25 minus 18 is going to give you this segment that's left. Okay, because we have the whole thing minus part of it. Whole minus part. In this case, we may not always have this, but in this case it is. So what is 25 minus 18? Well, that's going to be 7, right? So 7 centimeters is FG equals 7 centimeters. Okay? So I want you to pause this and I want you to go ahead and try these out. Okay? And on the next page, I'm also going to give you a couple more problems to try out. So 3 and 4 was included in the last page, but I want you to pause this one as well and do this last one, okay? Now this last one is algebraic. So I want you to consider that it is algebraic, which means that it may not say, 18 and 7. It may say 4x plus 1. So just for example here, before you do number 5, I'm just going to give you a quick example. So if we had, A, B, and C, and from A to B is, let's say it's x plus 1, okay? But we know that the entire thing from A to C is 7, right? So we know that x plus 1, we don't know what this is, okay? So we're going to say plus something else. So plus BC is equal to 7. So we're going to try and solve for what BC is, okay? Or let me go back. Let me give you a value for BC. So I'm actually going to tell you that BC is 4, okay? So let's just say that BC is 4. But we want to find out what X is, okay? So you're just going to solve this like a normal algebraic problem. So X is equal to 2. But does that tell me what AB is? Always look at the question and see what it says. It may say solve for X. It may say find the length of AB. Now, I've found what X is, but if I was looking for AB, I would need to plug that back in. Always remember that plug and choke property. So X is going to be 2. I'm going to plug that back in, and AB would be 3. Now this, I just solved a problem. I made this problem up. This is not one on here, so you'll need to pause it and do these problems that are here, but that is just an idea. So that covers the segment addition postulate, and I'm also going to be talking about the angle addition postulate, which is very similar to this. So catch me on the next video.